Large language models, or LLMs, which drive AI chatbots like ChatGPT, are highly effective because they are trained on extensive amounts of publicly accessible internet data. These models excel at summarizing, creating, predicting, translating, and synthesizing text and other content. However, their abilities are confined to the data available at the time of their training. To address this limitation, businesses are adopting techniques such as vector database, retrieval-augmented generation, and fine-tuning, which enhance the general knowledge of LLMs with current and specific information, making them more useful for enterprise applications. In our series of videos, we take first vector databases. A vector database is a type of database designed to store, manage, and search high-dimensional vectors, which are numerical representations of data. These vectors are typically generated by machine learning models and can represent various types of data, such as text, images, or user preferences. Let's dive deeper with an example query. Suppose you have a vector database containing vectors representing different images. If a user wants to find images similar to a specific image they upload, the process might look like this. The user uploads an image of a sunset. The system then converts this image into a vector. Following this, the vector database searches for vectors within the database. Finally, the database returns the images associated with the closest vectors. A healthcare organization wants to improve patient care by identifying similar patient cases for diagnosis and treatment planning. They decide to leverage vector databases to efficiently search and retrieve patient records based on similarities in medical history, symptoms, and treatment outcomes. Here's how it unfolds. First, patient records are converted into vector embeddings using advanced techniques like word embeddings or deep learning-based representations. Each record becomes a high-dimensional vector encapsulating essential medical information. These vectors are then stored in a vector database, specifically optimized for similarity searches. When a new patient case arises, the patient's medical data is encoded into a vector. This vector is used to perform a similarity search in the database, retrieving patient records that closely match the new case based on metrics like cosine similarity or Euclidean distance. Finally, by analyzing these similar cases, focusing on their diagnoses, treatments, and outcomes, healthcare professionals can craft informed, precise treatment plans for the current patient. The integration of vector databases in healthcare brings numerous benefits. Firstly, it enables personalized care by allowing healthcare providers to tailor diagnosis and treatment plans based on insights from similar patient cases, thus enhancing the effectiveness of patient care. It also promotes efficient knowledge sharing across healthcare teams, as similar successful patient cases can be easily identified and analyzed. Moreover, this approach significantly improves clinical decision-making and treatment outcomes by drawing from a diverse range of patient cases and experiences. Lastly, it optimizes resource allocation and healthcare delivery by identifying and applying best practices from similar cases, minimizing the reliance on trial and error methods. In summary, leveraging vector databases for healthcare patient similarity search empowers organizations to effectively utilize patient data for improved diagnosis, treatment planning, and overall patient care, ultimately leading to better outcomes and optimized resource use. Now let's consider the use of a vector database in an e-commerce setting to recommend products. Suppose a customer is viewing a product, for example, a red dress. The platform would then convert the product's description and image into a vector representation. By querying the vector database with this vector, the system can retrieve and recommend similar products, such as other dresses in similar styles or colors, thus enhancing the shopping experience by providing personalized recommendations. So this is our first video of the series on customizing AI models in business. Stay tuned with our next video on another technique known as retrieval-augmented generation. Subscribe to our channel, and don't forget to hit the like button if you enjoyed this video. Your support helps us create more content just like this.